Alright, boys and girls, welcome back to the drive-thru for a live third bell recording of a remix. I tried this yesterday and completely screwed it up. It was going so well, and then it just crashed fast. So let's try it again, okay? This is Chapter 11, Probability and Statistics. So welcome. I am so happy that we are done with points of discontinuity and asymptotes and all these things that don't really mean a darn in the real world. And now you're on to something that you can really use, whether you are in research or whether you like to go to the casino or whether you are a nurse. You're going to need to know how to interpret data, and probability and statistics is your key to that. It'll also maybe avoid the likelihood that you'll be fooled by fake news and be ignorant and otherwise unlikable. So, look, there's a lot to learn here. I'm going to do it in the most simple way that I can, but basically the key of this lesson is understanding the difference between a combination, which is a group of things, and a permutation. And that's a group of things that are assigned into a particular spot. So as we go through this lecture, I think you'll maybe get an idea of the difference, and then we'll also show you how to figure them out. So, as we stated, this is the hardest part, figuring out whether or not it's a combination or a permutation. Okay? And what you're really going to ask yourself is, does the order matter? Is the order that these things are selected matter? If the order does matter, then it's a permutation. Okay? If the order does not matter, then it's a combination. So if you're watching this video in my class, I'd advise you to pause the video at this point at remix and write down maybe these notes right here. Okay? All right. So what we're doing here is figuring out if these things are combinations or permutations. Let's say I have 5 free movie passes to give out to people in this class. Okay? I'm going to randomly select 5 people from this class to get free movie passes. How many different ways can these passes be given out? Well, we're not going to answer the question yet. What we're really trying to figure out is this a combination or a permutation? Does it matter when you are selected? It does not. The order doesn't matter. You either get picked to go to the movies or you don't get picked to go to the movies. So this one is a combination. Okay? Let's read the next one and decide whether it's a combination or a permutation. There are 8 racers in the 100-meter dash. How many different ways can we arrange the first, second, and third place finisher? Does order matter on those selections? Yes, it does. If the order finished Maddie, Abby, Lee, that would be a different result than if the order finished Abby, Maddie, Lee, or Lee, Abby, Maddie. So since the order matters, this is a permutation. You'd rather finish first than finish third. Okay? All right. 8 students will be selected for prom court from the senior class. How many different ways can these 8 students be selected? You're either selected for the prom court or you are not. Order does not matter. So this is a group of people. That makes that a combination. Groups of people are combinations. 3 students will be voted to be president, vice president, and class president of student council. The top vote getter will be president, second vote getter will be vice president, and third vote getter will be class president. How many different ways can this be done? Does order matter? Yes, it does. The first person is president. The second person has a different role. So this is not a group of people. It's people assigned to a specific role. So this is a permutation. Okay, so that's the introduction to combinations and permutations. Now let's talk about factorials. What is a factorial? Well, just so you know, this is a factorial. And to do this, you don't say 10. Okay, bless you. You do 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That is what 10 factorial equals. And I'm sure you're thinking, I don't want to type all of that into my calculator. Well, good for you. Okay? Because I don't either. Math is for lazy people that consider themselves smart. So, there you see what the answer to this is. It's 3,628,800. How do you do that? Well, you go to Math, and then over here on your probability, I hope this is showing up on your screen here for the video. If it's not, you might have to Google how to do a factorial on your graphing calculator. But there it is, down there, number 4. Okay? Oh, no, I do not want that. Make mine. So I do 10, Math, probability, 4, enter, and there you go. The answer is 3,628,800. Okay? So that's the next thing you're learning. How to do a factorial in your calculator, what a factorial is. All right. So now we're going to write down some equations for permutations and combinations. Okay? And then, more importantly, we're going to figure out how to do these in our calculator, because you're not really going to probably do these by writing out the formula all that much. Okay, so how many combinations, that should say of, how many combinations of R things can you make from a larger group of n items? So this is extremely confusing. So let me try to. So let's say we've got 4 people. How many different groups of 2 could we fit from those 4 people? Okay. So what this is, you would call this n choose R. Okay. Or n combinations R. And there's a button in your calculator for it. But what your calculator is doing, it's equal to n factorial over r factorial times n minus r in parentheses factorial. Okay, so that's the equation. You're going to want to jot that down, but you may not be using it all that much. Eventually down the road, when you get into a college statistics class, you're going to get into the nuts and bolts of it, okay? All right, so let's go back to our scenario. So let's say we've got, let's see, Grace and Nathan and Stas and Ashley, okay? How many different groups of 2 students could I pick from that group? So let's say I'm going to pick 2 of these people to buy lunch for today. Okay, I'm teasing you guys all class. So 2 of these people will be chosen for free lunch. Well, let's just list all the ways that I can choose 2 people. I could choose Grace and Nathan, nice little family lunch. I could choose Grace and Stas. I can choose Grace and Ashley. That's all the ways that Grace gets chosen. Okay? I could choose Nathan and Stas. I could choose Nathan and Ashley. Now, you might be writing, what about Nathan and Grace? I've already been chosen, so I don't need to write down Nathan and Grace. So the last thing that I would write would be Stas and Ashley. So how many different ways could I choose 2 people from this group of 4? 1, 2, 3, 4, 5, 6. So 4 choose 2 equals 6. Okay, now let's show you how the math works. That is 4 factorial over 2 factorial times 4 minus 2 fact. Oh, no. 4 minus 2 factorial. Okay? So don't be intimidated, just write it out for now. That's 4 times 3 times 2 times 1 divided by 2 times 1 times, this is 2 factorial, times 2 times 1. So it's 4 times 3 is 12, so it's 24 divided by 4, which is 6. Sweet, it worked. That's what I screwed up yesterday in the video. Okay? Now, let's go one step deeper. Hopefully you can see my calculator again. I don't never know if you can see it on the video or not. Okay? So, if you go to, let's go type in a 4, and then go to math, and go over to probability, and let's do 3. So NCR2, hit enter, and there you go. It'll do it for you. The answer is 6. All right, moving on. So, what's the equation for permutations? How many permutations of R can you choose from a larger group of n items? So this is n permutate R, and that's just n factorial over n minus R factorial. Okay? So let's do another simulation. Let's take the same group of people. We've got Grace, we've got Ashley, we've got Stas, and we've got Nathan. Now, this time, we're going to do a different little random drawing. If you get picked first, then you've got to eat a cricket. Okay? So first, eats a cricket. If you get picked second, you get an A on the final exam. So notice now that order matters. You probably don't want to get picked first unless you're hungry and into crickets. And you probably do want to get picked second. So now look, when we write these out, I could pick Grace and Ashley. I could pick Grace and Stas. I could pick Grace and Nathan. Now, do I need to write down Ashley and Grace? Is that different than Grace and Ashley? Yes, it is. Yes, it is. Because it's first and second. And Grace wants this one to happen, and she doesn't want that one to happen, right? She doesn't want to get picked first. So I could also pick Ashley and Stas, and Ashley and Nathan. I could pick Stas and Grace, Stas and Ashley, and Stas and Nathan. And I could pick Nathan and Grace, Nathan and Ashley, and Nathan and Stas. So notice, there are always, or almost always, more permutations than there are combinations, because the order of the selections matter. Okay? And so the answer that we get would be 4 times 3, there's 12. So now let's put that in our calculator. Okay? Let's do 4, and then go to math, and here it is, probability, and now we want 2. We want permutations, and look at the difference. It's 12. Okay? In case you're wondering, if we go back a slide, and we did 4P2, it's 4 times 3 times 2 times 1, divided by, well, what's 4 minus 2? It's 2 factorial, divided by 2 times 1, and those cancel, and you get 12, just like we figured out. Okay? So now we're going to go in, we're going to do some of the homework for you. So number 1, how many 2-letter pairs of one vowel and one consonant can you make from the English alphabet? Consider Y to be a consonant. Well, we got 26 letters. Okay? And 6 vowels, right? Or is it 5? A, E, I, O, U. So this is 5 vowels in this case, where they're saying Y is a consonant. And 21 consonants. So to figure this out, all you got to do is figure out, well, how many vowels are there and how many consonants are there? Because we're picking one vowel and one consonant. So this is a review of what's called the counting principle. And you just do 21 times 5, and the answer is 105 different combinations of letters. Okay? Alright, these you're just going to type into your calculator. So, 8, math, prob, enter, 4, oh no, clear. 8, math, 4, enter. And this is 40,320. Okay? So just break these up into 2 steps. It equals to, what's 11 factorial? Or let's do it all in one if we can. Let's see if we can do that. So, 11 math probability 4, close it, divided by parentheses 4 math probability factorial, enter. You get 1,663,200. So the rest of those you can put in your calculator. I'll get the key up to Blackboard as soon as I can. Almost done with the video. Alright, Art Gallery plans to display 7 sculptures in a single row. How many arrangements of the sculptures are possible? So those where the sculptures are going. Okay? How many options are there for the first sculpture? Well, you could pick any of the 7. Now, how many sculptures are left? There are 6 sculptures left, so now we can pick 6 for the second one. How many sculptures are left? 5, 4, 3, 2. There's only 1 sculpture left after you've already assigned the other 6 spots. So hopefully you understand that this is 7 factorial. So we just go 7, math, probability, and there are 5,040 different ways for you to arrange those sculptures. So that's the answer to part A. Alright, part B. If one sculpture is taken out of the show, how many different arrangements are possible? Well, then that one would be 6 times 5 times 4 times 3 times 2 times 1, which is equal to 6 factorial, 6, math, probability, factorial, oh no, not 66, 6, math, prob, factorial, enter. So notice, just taking one sculpture out reduces the amount of options you have for your display by so much. Okay? Alright, so I feel pretty good about what we've taught you guys here. So we'll just do number 22. This is very similar to the notes. So you type in the 12, and then you hit math, and then this is a combination, so we want to hit 3. And how many are we choosing? Well, we're choosing 11. And there are only 12 ways you can do that. Basically, if we have 12 people, how many different groups of 11 can we make? Well, it's basically saying how many different ways can we kick one person out of the group? And that's just 12. Okay? Make sure you do these and then check your answers. Alright, for each situation, determine whether you use a permutation or a combination, then solve it. Alright, you draw the names of 5 raffle winners from a basket of 50 names. Each person wins the same prize. How many different groups of winners could you draw? Got it. Order does not matter. That makes this a group. A group is a combo of people. So this is 50, choose 5. How many different ways can we choose 5 people out of a large group of 50? So we type in 50, math, prob. Let's see. This is we want to choose. This is a combo. not a permutate. So that's 3 and 5, 50, choose 5. We're looking at 2,118,760 different groups of winners. Later on in this chapter, we're going to be figuring out what your actual probability of winning is. Okay? Thanks for listening. Have a great day. Boom!